Welcome back, everyone, to our explainer covering Day 2 of Oz University's amazing 7-day cloud security series. So, yesterday we broke down the basics of cloud infrastructure, right? Well, today we're making a really vital pivot. Instead of just looking at how to deploy systems, which is what everyone focuses on, we're going to look closely at how real systems actually fail. We're intentionally breaking down a cloud misconfiguration scenario today. And look, this isn't to scare you. It's really to give you a clear-eyed, realistic view of how modern environments actually behave from a security perspective.
Take a look at this comparison. On the left side, we have what most cloud tutorials teach you, which is basically linear deployments. They give you this perfectly clean, straightforward path. Put piece A into slot B, and ta-da, you have a working server. But look over at the right. Real engineering requires a deep understanding of how those systems fail. Because honestly, very few guides teach you what happens when piece A just decides to stop talking to slot B, or when a default setting is secretly exposing all your data. The reality of cloud engineering isn't just about building things, it's about knowing exactly how the whole shebang can break apart.
So that brings us to Section 1, the deployment illusion, or as I like to call it, the trap of the green checkmark. And this brilliantly illustrates why it's incredibly easy to fall into a false sense of security when you're navigating cloud architecture. Step 1, an engineer follows a guide. Step 2, everything looks perfectly correct. Step 3, the deployment works just as expected. And Step 4, boom! Green check marks across the board. The system says success, so naturally you just move on to your next task. But guys, this is exactly where the danger lies. People are being taught to blindly follow these steps without actually understanding the underlying systems behind them. Which leads us to a massive, overarching question here. But what happens underneath the surface? Seriously, when you get those reassuring green check marks, what invisible realities have you just spun up in your infrastructure? Because the cloud, well, it isn't just a simple isolated machine. It's a vast, dynamic web of services. What you see on your little success dashboard, yeah, that is rarely the whole story. Moving on to Section 2, beneath the surface, we're going to look at how small decisions create hidden risks. Think about it like an iceberg. A seemingly small configuration decision quietly creates massive risk. Maybe you left a default security group open to the internet, or you gave an IAM role slightly too many permissions just to get a Lambda function firing quickly. It's silent. It doesn't trigger an error, no red flashing lights, but underneath the surface, that tiny, quiet choice has just planted a seed. And later, out in production, that invisible risk snowballs into a major, full-blown security threat. Most cloud mistakes are not caused by bad engineers. Listen, if you take away absolutely anything from this explainer today, please let it be this. It is so absolutely crucial to remove the stigma here. These incidents, they aren't happening because the people building our infrastructure are careless or incompetent. Not at all. They happen because of the incredibly demanding environments they are operating in.
And that leads us perfectly into Section 3, real-world pressures. This is why even the most experienced engineers still make mistakes. Because let's be real, real-world engineering is chaos. You've got deadlines, immense pressure, super fast deployments, massively complex systems, and totally misleading defaults. When you have a product manager breathing down your neck, a massive update rolling out in 2 hours, and a supposedly safe-looking default that suddenly turns out to be a huge loophole, well, that's exactly when misconfigurations happen. It's a highly demanding, high-stress environment where speed and delivery are constantly directly competing with absolute airtight security.
So how do we fix this? Section 4. Adopting systems thinking. This is all about moving beyond just memorizing tools.
So the crucial point is that systems thinking means actually understanding how cloud environments are structured, why configurations exist in the first place, and how all these services depend on each other. To genuinely secure modern cloud environments, we have to fundamentally shift our mindset. We have to move away from isolated tasks and start deeply embracing infrastructure thinking. You aren't just learning what a tool does, you're actively learning why it behaves the way it does within the larger ecosystem. It's about grasping the underlying logic.
Let's move to and see how this builds, because security is definitely not about locking down one single isolated resource. It's an entire web. It's about the relationships between resources. It's about permissions, knowing precisely who and what can talk to whom. It's about complex dependencies. It's about drawing strict access boundaries. Honestly, one weak setting on a seemingly insignificant resource, like an overly permissive S3 bucket policy, can so easily cascade through these relationships and ultimately compromise the security of your entire environment.
Now, what's really interesting about this slide is it brings us to the ultimate test of systems thinking, blast radius. This is the extent of the impact across your entire environment when one weak setting or resource fails. If one tiny piece of your infrastructure gets breached due to, say, a misleading default, how far does the explosion reach? Does it just take down one server, or does it literally tear through your entire database because of those interconnected dependencies we just talked about? Understanding your blast radius is absolutely how you anticipate the consequences of compounding failures before they even have a chance to happen. Which leaves us with one incredibly vital question to wrap up today's explainer. We know systems fail. We know hidden risks exist beneath the surface, and we know real-world pressure forces honest mistakes. So how do teams actually identify these dangerous misconfigurations before they become massive incidents? How do you spot that tiny flaw in the blast radius before the spark ignites? Well, that is exactly what we're going to explore tomorrow in Day 3 of Oz University's series, where we shift from understanding failures right into active detection. Thank you so much for joining me today. Keep applying that systems thinking, and I'll see you tomorrow to uncover the answer.